You've seen the headlines. You've definitely heard the names Ozempic, Wegovy. I mean, they're everywhere right now. But behind all that hype, there's this absolutely wild scientific story that starts with, of all things, a lizard and ends with a complete shift in how we think about the human body. So, let's get into it. We've all seen the buzz, for sure, but the real question, the one you've got to be asking, is what is this stuff actually doing inside our bodies to get these kinds of dramatic results? That's exactly what we're here to figure out. All right, so here's the game plan. We're going to start with the cultural explosion that's happening right now, and then we're going to rewind the clock to a seriously surprising origin story involving, yes, lizard venom. Then we'll dive into the science of how these drugs are like a brake pedal for your brain. After that, we'll look at the incredible promise versus the complicated reality. And finally, we'll look ahead to what might be a whole new frontier in medicine. But before that, if you're enjoying this content, hit that subscribe button and give this video a thumbs up. Also, drop a comment about what molecular story you want to see next. Okay, first things first, the phenomenon. Because let's be real, it feels like you can't go one day without hearing about these medications, and this is way more than just a health trend. It's a genuine cultural shift. It really does feel like they just appeared out of nowhere, doesn't it? Brand names like Ozempic and Wegovy, they're becoming as common as Tylenol. They've jumped from the doctor's office straight into the mainstream, and they're changing not just how we treat weight, but how we even talk about it. And this isn't just chatter. The actual data is, well, kind of mind-blowing. In 2023, semaglutide, that's the active ingredient in both of these drugs, was the 19th most prescribed medication in the entire United States. Out of everything, that is an absolutely staggering climb for a new class of drug. But here's the thing, this overnight success was actually decades and decades in the making, built on some really painstaking research, and, as we'll see, a few very unexpected twists. So this story actually kicks off way back in 1964 with this kind of strange discovery. Scientists noticed our gut responds way more strongly to sugar we eat than sugar we get through an IV. Fast forward to the 80s, and they pinpoint the hormone doing the work, GLP-1. But there was a huge problem. It vanished from the body in less than 2 minutes, making it totally useless as a drug. Then, the breakthrough came from the most unlikely place you can imagine, the venom of a Gila monster. In 1992, a scientist found that this lizard's venom has a super-powered, long-lasting version of that same hormone. It makes perfect sense for an animal that eats these huge meals, but very rarely. And that one discovery, well, it changed everything. So, how in the world do these lab-made versions of a hormone from lizard venom actually cause weight loss? Well, the answer isn't just about your stomach. Turns out, it's mostly in your head. It's kind of like a 1-2-3 punch. First, it perfectly mimics our natural GLP-1 hormone that slows down digestion, which, makes you feel physically full for longer. But the real game changer, the magic trick, happens in the brain. The drug goes right to your brain's hunger control center and fundamentally rewires your relationship with food. And to really get that brain effect, we need to know one key term, satiation. Now, that's not satiety, the feeling of being full between meals. Satiation is the signal that happens while you're eating. It's that little voice that tells your brain, okay, we're good. You can put the fork down now. It's the I'm done feeling, and that is exactly what these drugs turn way up. I love this analogy from the research. It's like the drug helps your brain step on the brakes. It boosts your brain's ability to anticipate being full, so you shut down the desire to eat much sooner. It's a cognitive thing, a learned response, not just a physical, my stomach is full feeling. The science is powerful, no doubt, but what does all this actually mean in the real world? Let's break down the good, the bad, and the complicated. We're talking results, side effects, and the huge question of what happens when you stop. Okay, this chart right here really says it all. This shows the promise side of the coin. It's from a huge clinical trial, and just look at the difference. After about a year and a half, the folks on the placebo lost a little over 2% of their body weight. The group on semaglutide, almost 15%. in the medical world, that kind of result is nothing short of revolutionary. But, and this is a really big but, what happens when the treatment stops? That's the other side of reality. Studies are showing that within just 1 year of stopping the drug, people regain, on average, 2/3 of the weight they lost. And this really drives home a crucial point. These drugs don't cure obesity. They treat it like a chronic disease, the same way you'd manage high blood pressure for life. And of course, there are the side effects. We have to talk about them. The most common ones are all gut-related: nausea, vomiting, diarrhea. And while for a lot of people these do get better over time, for some, they're just too severe to continue the medication. Then there is the massive issue of cost and access. I mean, just look at this. A monthly supply that costs nearly $1,000 in the United States is less than $100 in France or the UK. This crazy price difference, plus spotty insurance coverage, means that for a huge number of people, these drugs might as well not even exist. They're totally out of reach. But despite all these challenges, we are very likely just at the beginning of the GLP-1 story, because this is becoming about so much more than just weight loss. You see, it turns out that the receptors these hormones plug into aren't just in our gut and brain. They're all over the body. And because of that, researchers are now discovering this whole cascade of other potential benefits. This could fundamentally change how we treat a whole bunch of other chronic diseases. Just listen to this. Scientists are now studying GLP-1s to reduce the risk of heart attacks and strokes, and even to treat substance use disorders by acting on the brain's reward centers. There's also early evidence linking them to a lower risk of dementia and better management of kidney and liver disease. The whole field is just exploding with possibilities. But even as the demand is skyrocketing, that problem of broad access is going to be a challenge for a while. Because of really strong patent protections here in the US, we're not expected to see widespread, cheaper, generic versions of this stuff until at least 2031. Which brings us right to the ultimate question in all of this. The science is now telling us that, for many people, obesity is a chronic relapsing condition. So, if we start to see it that way, is a safe, effective, lifelong medication the logical next step? This is the huge, complex debate, medically and culturally, that the GLP-1 story has forced all of us to finally confront. Thanks so much for sticking around. If you enjoyed this content, don't forget to subscribe to Molecular Stories for more awesome stuff. Catch you in the next one.